Let's look at what are called hybrid functions. Hybrid functions are where we have a function that is made up of different functions over different domains. So this comes about in the fact that if we're modelling some real life data, and this is basically why we use functions, is to model things happening in real life, that over a certain amount of time whatever we're observing may be modelled by one function, and then at a particular point in time it'll change its behaviour, and then it'll need another different function to model that. It may be things like it might be the growth of the height of trees, and then for the first 1 year it grows at a certain rate, and then after a year it starts to slow down, and then it'll have another function to describe the time after 1 year onwards. So that's why we use hybrid functions. They're also called piecewise functions. Different pieces go to make up the function. So it's important to be able to sketch them, understand them, and to be able to calculate different values to do the what happens if types scenarios. Okay, so here we've got a hybrid function, and it's just made up of two. You can have more than two. You can have three different functions. And so for everywhere x is greater than or equal to 1, it behaves like x squared minus 1. And for everywhere where x is less than 1, it behaves like 3 minus x. So we're asked to sketch that. So we'll draw ourselves some xy. Well, actually it's not y, it's actually h of x. So we put x here and we'll put h of x up here. Okay, but just think h of x is like a y and this is like the y-axis up there. Okay, now it looks as though this is like a critical point, an x value that where it changes. So we'll locate that at 1. Everywhere less than 1, x is less than 1, it behaves like 3 minus x. Now 3 minus x, so h of x is equal to 3 minus x. That can be written as negative x plus 3. It may be worthwhile, even though x is not equal to 1, if x is 0.99999, it'll behave like 3 minus x. So as long as x is less than 1, it's going to behave like 3 minus x or minus x plus 3. So it may be worthwhile just to calculate h of 1. So that'll be 3 minus 1, which will be equal to 2. Okay, so it'll have to be, it does not include 2. So we go up to the point 2, and we'll just put a point there at the moment, and we know that negative x plus 3, it's got a negative gradient, so it's going to drop as it comes down there, and it's going to go through the point 3. So here it is here, straight line graph. Now because it does not include the value 1, we put an open-ended circle to show that it does not include x equals 1. So this part of the graph does not include x equals 1. So we've just found that endpoint, so we know where to put our open-ended circle. Now at x equals 1, we know that it's equal to x squared minus 1. So let's just see what happens when we go x squared minus 1. And if we put 1 in here, we get 1 squared minus 1, which is equal to 0. So it is going to actually start at this point here. And because it includes x equals 1, we will colour it in. Now, x squared minus 1 is like our parabola y equals x squared. Minus 1 moves it down. So it would be like ... if I just do a few little dots here. Nice parabola. So it does not include that bit, but then it goes up like this. Okay, so it does not include the dotted bit. And there's the graph of our hybrid function. This goes on forever, and that one goes on that way forever. Okay, so closed circle means it includes that value. Open circle means it doesn't include that value. State the domain and range. The domain is all value. Now, what values can x take? Well, it appears that x can go all the way to a negative infinity because this just keeps on going. This one, even though it's going up quite steeply, it goes on as well. So x is less than negative, x is greater than negative infinity, and it is less than positive infinity. Another way to write that is just open bracket, negative infinity, comma, infinity, and make it a round bracket. Okay, the range. What are the y values? It's clear to see that it can't have any values less than 0. This is the smallest value. The function stops there, and it can include 0, and then it can go all the way up to infinity. Now that's one way of writing it. Another way of writing it, now if it includes 0, we use square brackets, 0, comma, infinity, and for infinity, because it is a concept that approaches infinity, we use the round brackets for that. All right, so the next thing is to calculate h of 1. Now, if there are any x values less than 1, we would use this function here, 3 minus x, anything less than 1. Anything 1 or more, we use x squared minus 1. So h of 1, we're going to use that one. Now we've already done that down here. We're going to use the 1 squared minus 1, the x squared minus 1 piece of the function, and we get 0. So we're asked for h of negative 2. Negative 2 is out here, so we're going to use this piece of the function. So that would be 3 minus negative 2, and that would be equal to 5. And if we had h of positive 2, there's the point 1, there's the point 2, so we're going to use this part of the function. We would have 2 squared minus 1, 2 squared 4 minus 1 is 3. All right, so that's hybrid or piecewise functions. You can have more than just 2 pieces, but it's when you get 2 or more pieces that different functions that go to make up the one overall function. You're usually given a domain and range, a domain for the different x values for what each piece, where it is applicable. You can calculate the domain and range using the graph, and then we can calculate different values of the function.